Before you begin your No Calculator section for the SAT, remember that you're provided with the following formula sheet. Question 1. 8x plus 6 equals 6m. Since we want 4x plus 3, I observed that on the left side, if I simply divide by 2, I would get that expression, 4x plus 3. Therefore, I'll divide the entire equation by 2. 8x divided by 2 is 4x. 6 divided by 2 is 3. And the term on the right, 6m divided by 2, is 3m. Then I know that 4x plus 3 equals 3m. The correct answer is D, 3m. Question 2. For this system of equations, we're given that 3x plus 4y equals 18. And we're also given that the variable y equals 3/2 x. Therefore, let's substitute 3/2 x in for y into the first equation. It becomes, as written below, 3x plus 4 times 3/2 x equals 18. Then 3x plus 6x equals 18, 9x equals 18, and we find that x equals 2. Of the 4 answer choices, only answer A, 2, 3, could be correct. The correct answer is A, 2, 3. Question 3. We're given for this expression 3x plus 4 over 12 is equivalent to which of the multiple choices? Well, since it's a monomial, we can divide each term on top by 12, and we get x over 4 plus a third. The correct answer is C, x over 4 plus 1 over 3. Question 4. We're told that x minus 3 is a factor of the trinomial x squared plus kx plus 12. Well, that means that x minus 3 is the first binomial, and x minus some other number is the second, because, well, a negative times a negative would generate positive 12. Looking at my candidates, I found that x minus 3 times x minus 4 will create plus 12 on the trinomial on the right. Using FOIL on the left side, x squared minus 4x minus 3x plus 12 equals x squared plus kx plus 12. The middle term is negative 7x, which equals kx. So I write that down. Negative 7x equals kx, so k equals negative 7. The correct answer is A, negative 7. Question 5. Looking at the construction above, we see that AC is a diameter, and we're also given the angle 20 degrees. We're supposed to find angle x. By constructing triangle APB, notice that both AP and BP are radii. Therefore, triangle APB is an isosceles triangle. The base angles are both 20 degrees, and the obtuse angle that's missing is 140 degrees. Placing that angle, we see that along diameter AC, that the supplement to 140 is 40 degrees. Therefore, angle x is 40 degrees. The correct answer is C, 40. Question 6. Given that the nth term of bn plus 4 exists, we can generate the first 3 terms for n equals 1, 2, and 3. And we get that the first term, when n equals 1, is b plus 4. The second term is 2b plus 4. And the third term is 3b plus 4, and so on. This is useful to inspect the way the sequence works. And then we can simply try an answer that looks possible. For example, first I tried C, the average of the first 3. By adding these first 3 terms, I get that b plus 4 plus 2b plus 4 plus 3b plus 4 equals 6b plus 12. Well, when I divide it by 3, I don't get the desired value of b. So therefore, it's not answer choice C. Next, I tried answer choice B, the fourth term minus the third term. Well, when n equals 4, the expression is now 4b plus 4. And we already know that the third term is 3b plus 4. Well, 4b minus 3b is b, and 4 minus 4 is 0. Therefore, we found the correct answer. It reduces to b. The correct answer is b, the difference between the fourth term and the third term. Question 7. Knowing that m cubed equals the square root of the square root of n, recall that for square roots, the square root of n equals n to the half power. Therefore, m cubed is really the square root of n to the half. We're repeating that m cubed is n to the half, in parentheses, to the half power. The power to a power rule is used next. That states that any base a to the b power, then raised to the c power, is a to the b times c. So m cubed equals n to the quarter power. Since we want m on the left, we'll raise each side to the third power. 3 times the third is 1, so the left side becomes m. On the n side, n to the quarter to the third is a quarter times the third is a 12th. Therefore, the correct answer is A, n to the 1/12th power. Question 8. When computing the grass seed for this lawn, notice that it is a rectangle, so the area is A times B. We're told that one bag will cover 5,000 square feet. So for our first cost term, we take the total area, which is AB, and divide that into lots of 5,000 square feet. Then we have to multiply that by the cost per bag for each bag. So therefore, the total cost is AB over 5,000 times P, the price per bag. This is equivalent to AP times B over 5,000. The correct answer is B, ABP over 5,000. Question 9. If 5 over m is less than or equal to 2/3 where m is greater than 0, simply set them equal. Then 5 over m equals 2/3. When you cross multiply, 5 times 3 is 15. That equals 2m. So m equals 7/5, 7.5. If m is any number greater, then the fraction on the left will become something less than 5 over 7.5. The correct answer is C, 7.5. Question 10. We're given function f of x equals 3x plus n, and we're given that f at 2 equals 0. Plugging in 2 into the equation, f of 2 equals 3 times 2 plus n. Well, we know that f of 2 is 0. So 0 equals 6 plus n, and n is negative 6. Then we know that the true function is f of x equals 3x minus 6. Plugging in n, which we now know is negative 6, f of negative 6 equals 3 times negative 6 minus 6, which is negative 18 minus 6, or negative 24. The correct answer is A, negative 24. Question 11. S, T, U, and V are on the number line and they're labeled, and I just let each one be an approximate value, which will work for this equation. Well, S equals negative 3.75, T equals about negative 1.8, U is at about negative 0.5, and V a little more than 1, or 1.2. Then by plugging in each value into the absolute value bars, I see that the distance between S and V, the difference, negative 3.75 minus 1.2, will create the largest magnitude, negative 4.95. When I take the absolute value, that will be the largest value. The correct answer is A, the absolute value of S minus V. Question 12. Since 4 cosine x equals 1 between the interval 0 and 3 pi, I've simply graphed the cosine wave and shown the amplitude of 4. So the wave in the dotted red line peaks at 4 and has a minimum at -4. Notice that the midline is 0 because the transformation was only multiplied by 4. If I then draw the horizontal lines representing the height of 1 and -1 and show that bandwidth, notice that there are 3 locations before pi, before 2 pi, and before 3 pi, where the wave crosses the value y equals 1. There are 3 points. The correct answer is B, 3. Question 13. We know that I equals the square root of -1. What's also good to know is on the lower right that the cycles of I are the Klein four-group. I to the first power is I to the second power is -1. I cubed is -I, and I to the fourth power equals 1. These are useful values to know for the 4 answer choices we're about to plug into. One at a time, choice A is incorrect, because 2 times I squared is 2 times 2 times I, which is 4 times -1. So then we'll have -4 plus 4, which is 0, which is the same as the expression above. Choice B is also the same as the expression above. For 2 minus 2I to the fourth will be 2 minus 2 times 1, which is also 0. Choice C is correct, because 2 times I squared minus 2 equals 2 times -1, which is -2, minus 2 is -4. And choice D is incorrect, because I to the fourth is 1, so 1 minus 1 equals 0, which is the same as above. The only answer which is not 0 is choice C. The correct answer is C, 2I squared minus 2. Question 14. The vertex form of a parabola is y equals a times x minus h squared plus k. The vertex is located at the point hk on the coordinate plane. What's given is that y equals -1, parentheses x plus m, close parentheses squared, plus m. That means that h equals -m and k equals m. We're also given that m is a positive number, m is greater than 1. So we then know that the vertex hk is at the location on the graph of -mm. Since that's a positive m, the location of the vertex is in quadrant 2. The vertex -mm, where m is positive, I've drawn below on the quadrant plane, and the only answer choice where the vertex of the parabola was drawn with the vertex in quadrant 2 was choice D. Therefore, the correct answer is D. Question 15. Another system of equations question. Here, x minus 3y equals -2. And we're also given that y equals 5 over x. We can substitute in once again for the y value, and we get x minus 3 times 5 over x equals -2. I'll multiply everything by x to get rid of the denominator, and we'll get x squared minus 15 equals -2x. Setting this equal to 0, x squared plus 2x minus 15 equals 0. And then using my factor skills, the candidates that worked for 15 were 5 and 3. And I get the two binomials x plus 5 times x minus 3 equals 0. The correct answer is B. X minus 3 times x plus 5 equals 0. Remember to follow these following instructions when bubbling in your bubbled answers for the SAT in questions 16 to 20. Good luck! Question 16. We're given that 2/3 A plus a half B equals 5, and we're given that B equals the value 4. So like a system of equations, we'll simply plug in for B, and we get 2/3 A plus a half times 4 equals 5, or 2/3 A plus 2 equals 5. To get rid of all fractions, I simply multiply by 3, and I get 2A plus 6 equals 15, or 2 equals 9, and therefore A equals 4.5. The correct answer is A equals 4.5. Question 17. We're given that 6 over x plus 1 over 2x is an expression that it has to be less than 1 for integer values. Well, what I did was I combined them into one fraction by multiplying the first one by 2 over 2. Then I have 12 over 2x plus 1 over 2x, which is 13 over 2x. This is much easier to work with. Making a quick mini table, I noticed that, well, since 13 is the numerator, I guess I want to choose x values that are close to 13 to create fractions that are close to 1. So I wrote down the values between 5 and 10 on the mini table. Notice that if I plug in 5, I get 13 over 10, which is greater than 1. If I plug in 6, it's still greater than 1. But if I plug in 7, I get 13 over 14, which is less than 1. 8, I get 13 over 16. 9, I get 13 over 18. And 10, I get 13 over 20, and so on. So starting with the smallest value, x equals 7, and then going beyond that, I'll always create fractions for this original expression that are less than 1. The correct answer is 7. Question 18. I've decomposed this irregular shape into 2 rectangles. Notice that if I draw that horizontal line on the picture, that the top rectangle is 1 by 3, so it has an area of 3. And although I don't know what that red smaller rectangle is, I know the total area is 16 over 5. So therefore, the area of that small little rectangle must be 1/5. Well, since one dimension is 1, the other dimension must be 1/5. So now I have all the side lengths of my figure. Redrawing the figure, I placed 1/5 in that little corner next to the 2 and the 1. And then that long side on the right will be 1 and 1/5 extra. Finding the perimeter, so that I'm careful, I add the whole number sides first. 1 plus 1 plus 2 plus 3 is 7. And then the fraction pieces are 2 and 1 and 2/5. Yeah, so total the perimeter will be 8 and 2/5. Therefore, the correct answer is 8.4. Question 19. 6 over x plus 1 minus 3 over x minus 1 equals a quarter. Well, I remember my special knowledge from factoring that you can use the conjugate pair. So that will serve as the least common denominator on the left side. So on the left side, I'll multiply the first fraction by x minus 1 over x minus 1. The second term, I'll multiply by x plus 1 over x plus 1. Then I'll be able to make one fraction. That fraction will be 6x minus 6 minus 3x plus 3 over x plus 1 times x minus 1. Still equals a quarter. So then, simplifying the top, 6x minus 3x is 3x. Minus 6 minus another 3 is 9. Over x plus 1 times x minus 1 equals a quarter. By cross-multiplying, I get 12x minus 36 equals x plus 1 times x minus 1. I factored the 12 out, but then I thought, well, this is easier if I set it equal to 0. So I multiplied it back in, and it said, well, 12x minus 36 equals x squared minus 1. And then I can work out a 0. And it makes the trinomial x squared minus 12x plus 35. That factors to x plus 5, x minus 5 times x minus 7. Therefore, the correct roots or answers are 5 or 7. Question 20. This triangle ABC, we are told the entire area is 19 units. We're also given sides 4 and 5 of a right triangle. If you know the Pythagorean Theorem, you would write it down as a squared plus b squared equals c squared. That's on your formula sheet. The two legs are b and 4, here in the picture I've drawn, and the hypotenuse is 5. So we get 4 squared plus b squared equals 25. B will equal 9, b squared, that is, and b equals 3. So the base of the red triangle is 3. Now we can compute the area. The area of the red triangle is a half times 3 times the height 4. So the area of the red space is 6. Since we're told that the total area is 19, before we go to the blue triangle, let's take the total area 19 minus the red triangle, and we know that the blue triangle must have an area of 13. Then, again using the triangle formula, 13 equals a half times the base times the same height 4. So then we get 13 equals 2b, and 6.5 equals the other base. And finally, if I redraw the figure, focusing only on the right or blue triangle, BCD, notice that now I know the height is 4 and the base is 6.5. To find the tangent of theta, remember SOHCAHTOA, and the tangent is the opposite side over the adjacent side. Well, the opposite side is the height, or 4, and the adjacent or next to side is CD, which is 6.5. Therefore, tan theta equals 8 over 13. The correct answer is 8 divided by 13.